Good morning, good afternoon, everyone. Welcome to today's MBD discussion and demo with your SIS team. My name is Chris, along with my co-host Danielle. Okay, so without further ado, I will now pass the baton to Greg. Greg, good afternoon, sir.
Chris, Danielle, thank you. I want to welcome everyone. My name is Greg Walker. I'm VP of Sales and Business Development with SIS. First thing I want to do is go over the agenda, and then we'll dive right in to today's program. So we're going to give you a quick, literally a couple sentences on SIS. I'm going to recap on our ADFM program. It's our Aerospace, Defense, Federal, Marine OEM Supplier Program. We just had our previous webinar a couple weeks ago, and we went over that, but I'll have a few slides just to recap, because the MBD part that we're discussing today with PMI and the TDP stuff fits into it nicely. So we sort of want to dovetail the two together. I'm going to pass this over to Sevan. He's going to get into, technical data packets, some of the tools that go along with it, and really dive in to NX model-based definition demo, where he's going to really take a look at PMI, the processes, the benefits of using it, and hopefully blow you away a little bit about the tools that are built into NX. After he does that, he's going to actually go into a demo and show several of the downstream processes that take advantage of the model base that you'll benefit from it. At the end, we'll go over. We'll have a little bit of time for questions and answers. As Chris mentioned, you guys are all muted, so please make sure you put your questions in the chat. We'll queue them up, and we'll get to as many as we have time for. Thank you. And why are you attending today? If you can click on one of the reasons, driven by OEM customer, improving efficiencies with PMI, or general awareness. Okay, here we go. So it looks like most people that are here for general awareness, which is good, and then looking at the improved efficiencies. So hopefully the next time we do one of these, you'll understand why the OEMs are driving customers like yourself for model base and taking advantage of PMI. We'll go over that today. So thanks for responding to that. So again, I'm VP of Sales and Business Development here at SIS. We've been a platinum partner with Siemens for over 20 years. We've been in business since 1997. We're certified to sell and support almost the entire product suite from Siemens. And if you look at the circle to the right, it's branded Accelerator, for designing and realizing and optimizing all the different areas of your development, from engineering to analysis to manufacturing and quality, everything in between. So when you look at the products, we're here talking about NX CAD today and NX CAM. But Sim Center is all the simulation tools. Team Center is the PLM and data management. Solid Edge is your mainstream engineering solution, and it's a complete package for smaller companies that may not be as integrated in from their design to manufacturing. FEMAP and Star CCM are part of Sim Center, but they stand on their own as well. FEMAP is CAD agnostic analysis tool, and Star CCM is the leading CFD. Computational fluid dynamics solution out on the market right now. And then our Technomatics software, which really talks about process and plant simulation. We are headquartered here in Virginia, the Mid-Atlantic region. We have national coverage, but most of our folks are east of the Mississippi. So when you look at our customers, they're predominantly on the East Coast from Maine to Florida. But we support people in Hawaii too. So we really do cover the entire United States. Areas that we focus on, and one of the themes that we're talking about today is really this digital transformation. Why are we going to 3D, and why are we trying to do model-based definition? You guys have heard of digital twins. That's really what we're shooting for, is how can we represent reality in this virtual environment for you to run your business smarter, to be more agile, and to be able to use data reuse, which is one of the big benefits. We do manufacturing consulting, so folks that are machine shops, or if they're in production, anywhere in between, we're there to help and optimize some of the machines and talk about some of the modern capabilities that are out there and really help you along with that. We're experts on the NX post processors and simulation kits. So if you're using NX CAM, you have to have one of these to translate everything into G code so the machine knows what to do. And then in the process sim with the robots, it's the same thing with robots. So we do virtual commissioning with robotic cells as well. We do software deployments on-prem and in the cloud, and we really started our reselling business with the federal government. We have a GSA contract, and then in about 2005 we expanded into commercial, and we've just grown, all through the area. A couple of other areas that we focus on are academic and workforce development. So if you're looking, if you work with community colleges or colleges that you want to recruit from or you want to do joint stuff with, we can help grant them the software, the complete software, or the parts that are of interest to you. So just contact us and we could work on that with you. And then one of the biggest things that we really focus on is the Aerospace and Defense Supplier Program, which we had our webinar a week and a half ago. And that's what I'm going to cover. I'm going to do a little bit of recap on that before we dive into MBD. So when I talk about suppliers and the OEMs, if you're a machine shop or you're doing engineering analysis for one of these bigger companies, and maybe you're not doing it for them, maybe you're a third tier or a fourth tier, doesn't really matter. We have a program set up. If you can show us that you're doing business for Raytheon or Rolls-Royce or Boeing or any of these companies here at some level, we can help put a package together that really ties with a good discount structure. We can help you in this whole digital journey that you're on, and making sure that you're really connecting with their processes to help streamline their requirement to you for you to deliver the results, and to be able to improve your scorecard. When you work with these kinds of companies, they look at your scorecards for customer satisfaction, for cost control, for quality, for on time. We can help you lay out a perfect plan for that. So I'll talk to you at the end again, and we're more than happy to do a free assessment or have a conversation with you on any of these topics. So what does it really mean? The OEMs have these trends and implications, we call them. They're really looking at transforming their requirements to their suppliers, because they're doing much more and they're relying more on a supplier base. They have to be connected tighter. And so, how can they manage their capacity, their increased capacity, reduction of capacity? They do it through suppliers, so they can balance their loads with suppliers. But they also have to work on their, evaluations. They can't just, they're building aircraft, and they got to have, suppliers that are certified and that can deliver the quality product. And then they have to mitigate the risk, the supply chain disruption. We've been through that for the last 3 years. So we all understand that. So they have to look at that as well. And that's a big thing that they have to address. So they're passing a lot of this to the suppliers, saying, well, you really need a go through this digitalization process where we can give you digital data, 3D data, and you're sort of in our process or our workflow. So if we make changes quickly, you can make changes quickly. And you can reuse your data. You're not crunching up a drawing and starting from scratch, which I know a lot of people have done in the past. So it's really tying the process together, looking at the investment up front. So when you invest in working with that supplier, they know that you're investing in there. And we're helping that by giving you software and some of the things cheaper, and the training and things of that nature to get you up and running much faster. And then the last thing is really to be flexible. So their flexibility is going to drive your flexibility. So you're going to have to carry that same thing. Next. So when we look at this program, we're really looking to improve the OEM's customers' ability to meet their business objectives. It's really being driven by them. But we're here to help you benefit, because we're going to help the roadmap. We're going to be able to put something in and help come up with some best practices and help you extend their digital thread into your digital thread, so you can, drive the quality up, the cost down, and deliver improvements. Really be more agile in delivering the final results to the OEM. Next. So at the end of the day, we're looking at a supplier execution program where the first thing we do is we say, okay, yeah, you're doing work for them. We're going to get you qualified. So thumbs up. We're going to offer you the software that we're talking about today and anything around that, part of that accelerator circle I showed you earlier. And we're going to give it to you. We're going to get it to you in a 3-year commit at a really good discounted rate to get the buy-in, so you can then hire more people or invest in another machine or put your resources elsewhere. And then SIS, we're vetted through Siemens, and we're platinum channel partner. And the support that we're going to give you has all been vetted through Siemens. We're approved on the aerospace and defense program, so we can help you improve your scorecards and all these other things. But at the end of the day, we want you to get the business, expand your business, and make sure that your scorecard is giving you improved customer satisfaction out there. Okay, we're going to ask the second poll question. Are you currently machining or doing supply services with 3D data now, as opposed to getting drawings and doing manual efforts? Well, that's interesting, 50-50, okay. Well, so what you're gonna see today are things that are gonna help the people that are already using 3D, and certainly it's gonna help people that are using 2D that really need to get into this 3D arena. So, this demo and presentation today are really gonna, you can look at it from both different ways, but certainly the benefits of being in a 3D using PMI data is gonna help you through this digitalization process. With that, I wanna introduce Sevan. He's going to kick off a presentation on model-based definition, and then also do a demo for you. Sevan?
Good morning, everyone. My name is Sevan Davitian. Thank you, Greg, for the intro. I'm a senior applications engineer with SIS. My focus, my whole career has really been in manufacturing. I've always enjoyed it. Kind of grew up in a manufacturing environment, and keep on doing it because it's what I love. And since 2003, I've been working for race teams and companies that use the Siemens Accelerator portfolio, and here we are. So yeah, so that's a little bit about me. Just to kind of give you a little background, I've worked as a applications engineer for CMMs, machine tools, and mostly as a design engineer and manufacturing engineer, which will kind of help speak to what we're going to be going over today. So in this slide, what we're seeing is a progression that we hope all of you will be making, and it actually even shows history. Starting on the far left side, we've got what has been the norm for many years, which is you receive a drawing, whether you are an internal supplier or whether you are a standalone machine shop or manufacturing firm. Your customer gives you a drawing, and from that drawing, either you have people that are going to create a model from that drawing and then program to it, or maybe if you're lucky, you've received a drawing and a model. The challenge is, and the challenge has been what I've been subjected to, and probably many of you still see, is that then your programmers, your inspectors, your everyone that is involved in the cycle of delivering a part to the customer has to look at the drawing for tolerances, has to look at the model for some basic geometry, and then maybe there's some conflicts in between them, and you have to go back and forth with your customer, whether internal or external, and figure out, where's the truth? What is the desire? So the next step in the progression is model-centric. So companies have started to go towards a model-centric, call it enterprise or way of doing business, whereby you receive a model and the model is the master, but still at the same time, you're going to have to refer to a drawing. As you see in the image, we've got now a 3D model and we've got a 2D drawing that's going to have the dimensions, it's going to have your tolerances, and all of the information that is necessary to get the part done. The inefficient thing as compared to model-based definition and the way forward is that now my manufacturing engineer is looking at the CAD model and the drawing. My programmer is now looking at the model, creating toolpaths to the model, and having to look at the drawing and decide, am I boring, am I reaming, am I just drilling and tapping? And he's deciding a process, looking back and forth at the two things. And then we go to inspection, and my CMM programmer has to load the model into his software, and then he has to look at the drawing and he has to enter all of the information as far as GD&T, the nominal dimensions, you know, where my datums are and all of those kinds of things, which can even be hard to find. I mean, if you're dealing with a large part, oftentimes it can be difficult to find those datums. It can be difficult to find dimensions related to a feature. So as we move forward now, we're rolling into model-based definition, whereby you're looking at a 3D model. And as you can see in the image, all you have is the 3D model and the dimensions are there in 3D with it. And you'll hear the term used in the Siemens circle, especially where everything is centered on an X, and you can be in one application and do all of these things. But you'll hear the term single source of truth, where instead of having to drift back and forth between a model and a drawing, everything is in your model. You deliver a model to your supplier, and that has everything in it. There's no questions about who reigns supreme, about where I should get my information from, and what is truth. There is one single source of truth, and the best part as we transition into a model-based enterprise is the time savings. As you see in the last image there, we've got, you know, you may receive as a machine shop a technical data package. That technical data package may be as simple, and as you'll see in the demo, as a 3D PDF. Inside of that 3D PDF, which is born from from the MBD model, you've got the CAD model, you've got anything needed. Essentially, a 3D PDF is kind of like a zip file of old, where anything that's necessary can be contained in there. And that's whether that's what you receive from an OEM. That can be what you deliver to your shop floor. If you're in manufacturing, you can deliver the part program in a 3D PDF. You can deliver views from your CAD model. You can deliver an inspection program. Everything can be contained in that 3D PDF. And again, speaking back to a model-based enterprise, instead of having your CMM operator enter all these dimensions and tolerances from the drawing, instead of having your shop floor, the machinists, instead of them having to go back and forth, look at the drawing and look at 50,000 different things, go into CAD and look at the model and get some, you know, because oftentimes the machinists might measure the part or do their inspection on the shop floor differently than how the drawing is. So oftentimes they have to go in and get a calculator out and either add some dimensions from the drawing or what have you. All of that can be done in your 3D PDF. or if you've supplied them with a station on the shop floor, they can do it in NX or in the 3D PDF. So yes, the model-based enterprise is one where you have the single source of truth, which is your CAD model with your PMI. That information is used and deployed, as you will see soon, in creating the staged models. It's used in NX CMM to do your inspection. It's used for your first article inspection. Within the Siemens Accelerator portfolio, there's a specialized tool for first article inspection where you can communicate to your supplier or to the OEM or to your internal external customer all of the dimensions and inspections from the first article inspection. If we're in the design aspect, or really even in manufacturing, you've got NX VSA, as you'll see, and we can probably transition to the next slide now. And you'll see that in NX VSA, which stands for virtual stack-up analysis, you can take and apply those same dimensions and tolerances on every part. So here in this image, you're seeing a propeller that might be used on a ship or on a submarine, and you've got datums, you've got all of your dimensions. NX VSA will take all of these dimensions and those tolerances, your maximum material conditions, and it will exercise every part in an assembly. So here we're just looking at a propeller, but for instance, if we're looking at a ship and we've got, starting back at the propeller, we've got a propeller mounted on the shaft with a retaining nut going through some mounts into the hull and attached to a transmission, then an engine. Well, based on tolerance stack-ups, that propeller might be able to wobble around, the shaft may be able to wobble around, and all of those things can be displayed in NX VSA and show you what the worst case scenario is or the best case scenario of your assembly. And companies like Boeing, Northrop Grumman, they will use it to determine if there's a problem in their stack-ups and with positioning and maybe fluctuation of components. But also in the machine shop, we can use it. Let's say I'm mounting this propeller to a fixture and I have a true position tolerance of, I don't know, a couple of thousandths on a dowel pin hole or on a drilled hole. Well, if my clearance to my fixture is too great, I'll be able to analyze that and get an idea of whether things will repeat and I have a chance of being within tolerance or not. So yeah, we can go to the next slide now. So yeah, so here we're seeing in greater detail what I was speaking to, which is on the left side, on center, you've got your model with all of your MBD, and that goes back and forth with your PMI Advisor. So let's say I receive a file from a customer, and similar to a drawing, you have all of your information, but it's in the 3D model. As you will see in a moment in the demo, I can run the PMI Advisor. The PMI Advisor is essentially a virtual or digital GD&T expert. I can set all of my rules, whether they be pertinent to my machine shop or to my business or enterprise, and I can have it check and make sure that the tolerances don't have any mistakes. I've intentionally, as you'll see, put an error in the model, and we'll see if the PMI Advisor catches it. And then we can talk about fixing it and so on. Then again, from our MBD, we can go to staged models. Gone are the days of having to have 5 or 6 different people that are experts in NX. As you'll see in the demonstration with staged models, a process engineer with a half a day of training can go and can delete out features so that when the part models are delivered to the programming staff, they will look as they need to for the initial stock model, and they will look as they need to, as far as, let's say, for instance, we're milling a groove or turning a groove. So you can quickly generate the models and send them to your internal, external customer. The TDP, as I mentioned, is a technical data package, and I will show you in the demonstration how we will take our PMI and quickly translate it into a 3D PDF, and how the shop or how anyone can deploy the 3D PDF, which the PDF is one method of communicating the data. And I believe I mentioned, but TDP stands for Technical Data Package. And so it's your, it's all of your data, all bundled up in one neat file. I mentioned NXCMM and the fact that all of the data, I mean, essentially, it blew my mind. I loaded a model into NXCMM the first time, and without training. So that's another thing about the accelerator, is that everything is in NX. NX is your central tool. And once you know NX, everything is very intuitive. NXCMM is very similar in nature, and it's founded on NX manufacturing. So I was able to go in there and load my model, load a machine, hit the reuse PMI button, and essentially when you hit reuse PMI, it brings up a dialog and says, do you want to also create your inspection program? And off it goes, and inside of 30 seconds, it will look at the features that, say, a surface profile is associated to, and it will automatically select AB probe angles and go and inspect that feature in order to create an inspection. And best of all, for a guy like me or anyone who's programming a CMM, I no longer have to take the tolerances and enter them for my nominals, for my tolerances and all of that stuff. It happens automatically, literally in 20 seconds. And we already mentioned the first article inspection, how all of that information washes into there. And I will show you as well a quick glimpse into programming and the PMI, how it can be used to automatically determine. There's a knowledge fusion and feature-based machining in NX, and you can set it up to look at those tolerances on the hole. Let's say we have a hole pattern, and some of the holes have a plus or minus 10 tolerance. NX, through the knowledge editor and any information you give it to suit your business, it will decide whether that hole can just be drilled. It'll decide if it needs to be drilled and reamed or drilled and bored, and it will give you the tool paths, and then you can approve and use them or not use them. And then, of course, again, through an XCAM, you can create your electronic work instructions. Okay, so on my screen here, you should see the model of the propeller. And you will notice on the left side here of the screen, I've got model views. So right now, I just have a clean view of the propeller. And then what we do in PMI is we organize our PMI into views similar as you would in a drawing. So in this view, I now have all of my PMI, and you can see, you know, my datums, my A, B, and C datum. I've got some feature control frames. I've got a bolt circle, a bore with tolerances, and a hole call out. And essentially, you organize everything as you would. And actually, this is a choice. Most of the OEMs, if you receive a model from them, this is how they work and how they organize it. But you can quickly go and see what the bottom drawing view would look like, the front drawing view, an isometric. and so on. So it makes it easy to organize the dimensions. Then of course you can go to an MBD query, and let's say you've got a huge model of, I don't know, a Boeing 757, and you want to find a datum, or you want to find anything related to a diameter. You can do a text-based query or a rule-based query, and you can quickly go and find your PMI. So let's see, I guess, step into the PMI Advisor. So here, like I said, we've got, oh, and maybe I haven't mentioned this, but PMI stands for Product Manufacturing Information. PMI is essentially the foundation on which model-based definition stands and is built on, and which, of course, a model-based enterprise is built on. All of your information that is needed to manufacture the part, whether it be the material, the geometric tolerances, the sizes, they are defined in PMI. And so the PMI Advisor is what we use to take a look and make sure there aren't any errors. So it's as simple as coming to the HD 3D Navigator here and hitting Run Advisor check. And then I want to look and see if everything is okay, and I can see some green check marks. I'd probably like to see if there's any errors, warnings, information, and so I will click and show everything here. And you can see that most everything has a check mark, but this feature control frame here has a problem. And let's see, so it's shown here, and I want to go and fix that. So let us go and find our feature control frame. And essentially, when I find it, I will go and edit it and remove the problem. So here we will go ahead and we will edit it, and I get this dialog, and here are all of my options that I have to add to this feature control frame. And we will go and remove our problem. Oh, it says here, by the way, so feature control frame has warnings. A material modifier may only be applied to a feature of size datum reference. So I had a max material condition in a place where it's not applicable, and we'll say okay. And then we can go back and rerun our advisor check, and you'll see that we now have all green check marks and things are happy. So that's a quick glimpse into the PMI Advisor and how it can be your on-site GD&T expert and verify and check your models for, and this is really whether you are designing the part and applying your tolerances and your dimensions, or this may be when you receive it from an OEM and you want to make sure that there's no conflicts or there's no issues with it. All right, so let's take a peek at staged models now. So here now, I'm going to be a process engineer, and I initially received the model of the propeller, and I'm creating stages. So essentially, this here on the right side of my screen is my finished model. And maybe I've got stage 1 here, stage 2, which can be op 10 and op 20. I'm just going to quickly come here and show you if I'm creating a model. Let's say we're creating a blank for this next operation here. I will wave link to this model, and I'm basically creating a link of it, or a copy of it that is fully associative. So the important thing to know here is this is our master model, And let's say our supplier makes a revision change, and I don't know, maybe the number of holes decreases or tolerance changes or the bore changes. All of these models are associative and the information will update. But let's say we're going to machine these holes now. It's just as simple. I'm going to go to delete. And let's say in this operation, we're going to mill this groove. And we are going to machine the holes. All right, so you can see we've now deleted the groove. And maybe let's go ahead and delete the holes as well. And so you can see just how simple it is for a process engineer or whoever your planner is to go ahead and make modifications and then send them to the shop for them to use. So in NXCAM, I would then have this as my blank that I'm starting with, and then this would be my finished part that I would be machining to. And of course, in the background, NX will use all of this data, the PMI, to determine what kind of operations we need and how to go about it. So next, let me show you, we will go back here and here. And in my PMI tab, I just want to show you, we have technical data package here. It is as simple as hitting publish and selecting a template. So I can create templates, and these are actually out-of-the-box templates from Siemens of what views and such that I want to create, what the layout is. Choosing to do a 3D PDF, and then the model views. Let's say I only want to include my PMI including views and not any of the basic ones. I can select to do that. For security, I can apply a password so that if anyone gets a hold of the file in the company that shouldn't necessarily have it, or whatever your reasons may be, you can set a password to it. And then here in the attachments tab, I can go navigate into Windows and find any files that I want to attach. They can be pictures, they can be a CAM program, they can be anything under the sun that you want to send with the technical data package. And I'm just going to hit cancel here and just show you the end result that you would get, which is this 3D PDF. This is, as you can see here, I'm in, I think it's Adobe Reader. Yeah, it's one of the, Adobe Acrobat Reader, standard free download. You can see this is a 3D model here. I can zoom in and look at my dimensions. And best thing ever as a programmer is I can quickly go and find things. So I want to find where my datum A is. I want to find where my datum B is. You can see it's highlighting and changing to a view where I can see it. I can quickly snap to my PMI bottom and roll around my front, so on and so forth. And then let's say this arrives at the shop floor, and the guys on the shop floor just want the views so they can have a piece of paper taped to the machine. It's as simple as coming here, checking which view you want or which views you want, and hit print, and you can create a paper drawing that they can have on the shop floor. And that's, again, that's another thing that I didn't mention, and I probably didn't speak enough to, but you create your model-based definition file, you have a drawing for free. Let's say you need the guys on the shop floor, they don't have a workstation to look at it in 3D, and all they have is a place to hang, or let's say for your traveler that goes with your part, you want to have a sheet of paper. All of that is free. You can essentially come here and print it, or even from the NX interface, as I showed you the organization, you can go to the top view, hit print, and you've got quickly a drawing. And all of this stuff immediately updates as we make changes in CAD. It automatically regenerates. So that is the technical data package. Here on the left side, you will see in Adobe attachments, and I don't know if I have any attachments. Yeah, you can see in here, I've got the part file and I've got a JT of the part file. And so those are attached in here, and I can go and I can save them out from here into my computer. It's just a Windows dialog, and I can go to my documents or wherever and save them out. And again, this is just standard Adobe. Nothing.
Hey, Sevan,
Yeah.
we're running out of time, and you know, we are going to have a follow-up thing in a couple weeks, a lunch and learn I can talk about, and we can dive in deeper. But
Okay.
I think we need to wrap this up because we're running out of time.
Yeah. So yes, anyone who is interested in seeing deeper into things, I didn't really get to show you in the next cam, but you can see I have the propeller here in a 2-channel machine. But yeah, I think we really covered everything. And if you have any questions.
We're going to have a lunch and learn, and we can go into these topics a little bit more, and it can be more interactive too.
Yeah,
so
absolutely.
we're going to talk about that, and it'll be posted on our website as we wrap up. I'll mention that.
Yep.
We also had a couple questions come in, so I want to make sure we get to these before people drop off.
In summary, what we've seen today is that NX is the core. It is the center of our manufacturing process. We design in NX. We add our PMI to create MBD. We can program the CMM, do our process, figure out our process, send the models, do our first article inspection. Everything that you need happens in NX. And I guess you're probably not seeing my screen anymore, but I can show you in a demo that essentially from within NX, you choose which environment you want to be in, and you transition right into it. The CAD data can come from any source, whether it's a NX part file, a JT, a step 242. NX is able to use the PMI data from there. So as you can see, we're able to leverage the power of a JT file, and you really minimize and actually eliminate the need to go into a variety of other systems. You can do everything you need within NX. And therefore all of our data is better managed. There's no need for import, export, and making sure which version of what file is where. Literally in one click, you can update everything, and everything will be current. Reducing or eliminating escapees that may happen because maybe I send a program to the shop floor that is based on a different version of the file. Everything is self-contained and version and revision managed. So yeah, that's it. I look forward to hearing from anyone that would like a deeper exploration into NX, and we will gladly show you more in detail what you want to see.
Thanks, Sevan.
Yeah.
Yeah. So just sort of, I wanted to do a quick recap. I know we're a few minutes over. Appreciate you guys hanging in with us. So the ADFM program that I mentioned in the beginning, if you guys are looking to do work, or you're doing work with one of these aerospace and defense OEMs, please contact me. And my contact is on the screen. We'll be happy to talk to you about it. We'll do a free assessment if there's areas that you're looking to improve, and really understand your current state and come up with something that we can help you move forward with. The second part is, model-based definition using PMI. Hopefully you're able to at least get a quick look and see what it is. And again, it's all about data reuse, the digitalization that we're talking about for automation when you have the whole environment going. Achieve quality metrics where, you need to meet your cost targets to stay in business and to pick up more business, and make sure you have delivery dates and work on great scorecards. So that's exactly what we're here to help you with. We're going to be posting this lunch and learn for PMI and MBD coming up. It'll be a free event. It'll probably be an hour and a half over lunch in about two to 3 weeks. 2 quick questions that came in. Maybe Sevan, can you help me answer? I have a neutral file. Will PMI come along with it if I have a neutral file?
The format, does it say it?
It just says if I have a neutral file, will PMI come along? My guess is no, but you could bring the neutral file in and add PMI to it. Or if it was a JT file that was a derivative of like NX, you can export PMI into the JT neutral file.
Yeah, actually, I think the answer is probably yes. I mean, the term neutral is just basically is usually used in industry to say that it's a CAD neutral file that can be important to any system. And so that may be a STEP file, and absolutely, we can use PMI from STEP. We can use PMI from JT.
And we'll reiterate these in the session coming up. I just want to get through the last one real quick, Sevan, because we are over. Is it true if I have an MBD file that everything will be in there to machine it?
I mean, it depends on the supplier, as you saw in the 3D PDF, which is one form of an MBD file. You can have everything under the sun in there. Like I said,
it's got the capability to hold all the information.
Absolutely, you can put anything you want in there, kind of like a zip file.
But that's it. If there's any more questions, please email me. My email's on the bottom. We'll get the lunch and learn thing out to you guys, and would really be interested in talking to you to see if you qualify for the ADFM program. It's a really good program that SIS is leading the way with Siemens and their partners, and we're really proud to be doing this.